Hi everyone, I'm so happy to be here. Unfortunately, I could not join you physically as the original plan. However, I'm here and I'm happy to be here and lecturing, and I'm hoping this is not my last time. So my name is Ola Spiel, and today I'm going to share with you a lecture about GCP, about exfiltration in GCP, how you can detect it, how you can investigate it, and you will learn a couple of ways an attacker can abuse services and APIs in order to do exfiltration in GCP. Before that, a little bit about myself. So again, my name is Ola Spiel. I'm the head of research at Mitiga, which is a company that's focusing on cloud security, detection, incident response. I have over 10 years of cybersecurity expertise, both as a developer and as a security researcher. And I'm a former salsa dance instructor. Yeah, this is about myself. And by the way, this is Chief. He will join us in the lecture, and you will see him a couple of times in the lecture itself. So, exfiltration GCP. What is exfiltration exactly? Exfiltration is all about stealing your data from your network, from your endpoints, from your resources, and cloud included. A couple of assumptions that you can assume regarding to exfiltration in GCP. First of all, the attacker already compromised your cloud, your environment, because they cannot just steal data and that's it. They need to have some kind of initial access in your environment. So I will show you later how it can be done. The second part is that don't assume the attackers will do the direct way to steal data, such as just downloading data from your buckets. They can abuse different ways and different services in order to hide their actions and jump between gaps, security defenses. And the last part regarding to detections is that the logs that GCP provides you are your best friend. This is the tool that you will use in order to detect, in order to investigate malicious actions. So about the lecture, I will start with an introduction. Then later on, in order to really understand how you can detect exfiltration, we'll go deep dive on logging, on GCP logging, focusing on specific log called the Google Cloud Audit logs. Then I will show you a little bit about how you can ingest those logs. And then I will give you a couple of examples from popular services in GCP, how an attacker can exfiltrate, and how to detect it. We will finish with a summary and questions from your side. So let's start. So how an attacker can have permissions in your environment. I gave here 4 examples, but of course there are more. The first example is leaked service account keys. As you know, there are identities called service account in GCP. And one of the ways to authenticate as the service account is using a service account key, which is more like a password, like a programmatic access of a user in AWS, for example. And if the attacker has access to those keys, they can authenticate as the service account and abuse using the permissions. The second example is compromised user after business BEC attacks, successful BEC attacks, phishing attacks. The attacker can abuse the identity or the endpoint which the identity work on, and from there exfiltrate data from the GCP. Another option is rogue employee, a good employee which turned bad and steal the data for their own usage. So this is another case. And another case is compromised machines. If the machines have permissions to do stuff on your GCP cloud, if those machines get compromised because of 0 days, Mondays, other days, so they can run as those machines and then exfiltrate data from them. So I gave you a couple of examples how an attacker can have permissions on your environment. And about GCP logs, which is very important to understand in order to know how you can detect and how exfiltration can look like. Here I gave a couple of examples of which logs Google provides you, but of course there are more. There's VPC flow logs, there are cloud audit logs, load balancer logs, and storage usage logs. VPC flows is about network, cloud audit logs we will focus today, and load balancer logs about metadata of HTTP connection, and storage usage logs are things that happen in your buckets. But again, we'll focus today on cloud audit logs. So what exactly is cloud audit logs? It records API actions that happen in your environment. It answers questions like who did what, on which resource and when, and all the things that the person do using the API, you will see on those logs. And this specific log, you can split up to 4 different categories: admin activity audit logs, data access audit logs, system event, and policy denied. But today we'll focus on admin activity and data access inside cloud audit logs. So admin activity audit logs are actions that some administrative actions that happen in your environment. If I'm comparing it to different cloud provider, it's like activity logs in subscription in Azure, for example. And gives you only the admin right operations, such as creating resources, deleting resources, modifying resources. This log is enabled by default. And in order to see that using GCP, you need to have the permissions on the left, which is logging viewer. Examples of such actions that will be covered in admin activity logs are in Compute Engine, creating new instances, in BigQuery, creating tables, removing tables, cloud storage, changing existing object ACLs, creating buckets, and in Cloud SQL, start DB replications and connecting to instance. So this is admin activity logs. Data access audit logs, on the other hand, are covering your data activity inside those resources and reading metadata of those resources, what we called admin read. So if I go back, admin activity is all about admin write, and data access is admin read, and data write. Another effects about this log, this is not enabled by default. You need to explicitly enable it for every service, and it's not generated for publicly available resources, as you will see later on. In order to see those logs, you need to have the permissions of logging private log viewer. How you can enable those data access logs? Here is an example in the console. You choose for a project or organization, you choose the specific service that you want to enable those logs, and you can choose the category, admin read, data read, and data write. In this example, you see that everything is checked, so you get all the data activity from the enabled services. Examples of such events are in Compute Engine, listing instances, getting permissions, BigQuery, reading tables, appending data to a table, in Cloud Storage, listing buckets, reading objects, and in Cloud SQL, creating DB user, exporting SQL dump file, and more. So it's all about data activity inside those resources. So now we'll have a quiz. Unfortunately, I can't see you, so I'm assuming that you will answer the questions in a good, exactly as it should be. So now you need to choose if it's an admin activity or a data access. In which category is it? So copying objects in buckets, what do you think? This is an admin or data? So I will answer. This is a data access audit logs. It covers in data access. Set labels on compute instance, like a VM, setting labels. What do you think it is? This is an admin activity audit logs. Execute SQL query on Cloud Spanner. Cloud Spanner is a different service in GCP. This is, of course, data access. And the last one, reading blobs from storage accounts. What do you think? This is a data or an admin? So if you choose admin or data, you are wrong. This is an Azure blob storage account. This is from a different cloud. I just want to check if you are alerted. Fail for everyone that choose wrong. This is Chief. Okay, so the last part about the logs, and then we'll go deep dive about the format of the logs, is how you can ingest them. So there are a couple of ways. You can use Logs Explorer inside the console, which you can query the logs, filter them, and you can use gCloud CLI or API in order to filter them and get them. Let's talk about the audit log format, and then we'll go to the exfiltration examples. So this is how the log looked like. I removed all the dynamic parts, which are different for every API. And let's focus on specific critical information that is inside the audit log. So log name and timestamp. In log name, you will see from which type of log it came from. And here you can see on the end, this is a data access that came from project one, and the timestamp when the action happened. In the identity part is the authentication info, which is explained to you who did the action and the IP and the user agent that was used. Specifically in this case, this is a service account inside project one called Mitiga, which did the action. In the authorization info, which sometimes get missed because people don't look at it, you will see the permissions that were used in the API. In this specific case, the permission of get IAM policy was used in Snap1 snapshots. and service name, method name, resource name, explain more about the service that was used, the actual method, and on which resource it happened. So if I conclude everything, you can understand in this case that on snap one, there was a get IAM policy action by a service account called Mitiga in this date, in this color, in this IP and user agent. So let's reach to the good part of the exfiltration. I'm focusing today on 3 popular services in GCP. I will start with cloud storage. And let's start from the basic parts. So of course, in cloud storage, this is the S3 in AWS or storage accounts in Azure. Resources that you need to look for are buckets and objects. And let's start again with the simple form of exfiltration, which is directly downloading the object from a bucket. Let's assume the attacker has the permissions of object get on your bucket or on specific object. And this is in the left, you can see example of how an attacker can downloading data from your buckets. On the right, you can see the log. So let's focus on specific parts of the logs. In the request, you can see the actual object that was downloaded, the resource name, and which object was downloaded. And in the response, you will see metadata information about the object. So it sounds like it's very simple to detect, and you just need to look on data activity logs. But yet again, there are problems in how to detect it using the logs. The first one, as I said earlier, this is a data activity. So it's inside the data access logs. And data access logs are not enabled for public resources. So if the bucket is public or the object is public, you won't see the get logs. How it can happen? Maybe you put critical information inside a bucket. Maybe the attacker changed the bucket to a public and then downloading the object. So you can use a different log, which called storage usage logs, in order to see public activity. But yet again, in admin activity, you won't see anything. And the last problem is granularity. Specifically, if I'm jumping to AWS, for example, in AWS, you have get object and you have get object metadata, which you want to just look at the metadata of the object and not download not see the data itself. Why you want to do that? Maybe looking at the tags, about permissions, about the object, the size, and more. And in GCP, everything is inside storage object get function. So think about maybe you have some TTP which is anomaly detectable if you see like a lot of get objects, but yet again it can raise alarms like false positive alarms. So how you can still differentiate between downloading file and get object metadata by looking on authorization info. As I said earlier, authorization info gives information about permissions that were used in the API. So in downloading file, you will see only object get. But when you do get object metadata, you will see also get IAM policy. Why? Because when you read the get metadata, you will also read the permissions that identities have on the object itself. So this is a cool way to differentiate between get object metadata and down the data directly. So in this example, I showed you the direct way to exfiltrate data from your buckets, but there are more ways. And now I will show you a different way, which is using a service which Google provides you that's called storage transfer service. This service helps you automate transfer of data inside and outside of your GCP buckets. And this service uses their own identity, which is a service account. That this is the format of this service account. You have the project number, and storage transfer service as a domain. And it uses the permission of this service account and run as this service account, not on your permissions. So how attacker can abuse it? First of all, the attacker needs to give this service account permissions to read from the bucket that you want to steal data from. Then let's assume the bucket, which is the attacker's bucket, exists in a different organization. So I need to give this service account permissions to write to the bucket, to the attacker's bucket, and then just creating the transfer job. And the transfer service will do the exfiltration for you. So how it looks like in the log. So of course, you will see the adding permissions on the source bucket. You can see here that this specific service account got permissions to read from the bucket. And you see here the permissions legacy bucket reader and object viewer. And the next log that you will see here is the actual, the transfer of the data using this service account. You will see a lot of get, list and get, list and get, as you can see here, but that's it. You won't see any logs except the get from the source bucket and the changing of the permissions on the bucket. And why? Because if the bucket exists if the destination bucket exists in a different organization, you won't see the logs from a different organization, because you will only see logs that happening inside the organization, inside the resources in the organization. So you won't see the right permissions that was given to the service account. And you won't see, of course, the right object to the destination bucket, the object right, because again, the bucket exists in a different organization. And the last part, which I think is the worst case here, is that you won't see the creation of the transfer job by default. So you cannot know exactly if the bucket exists in a different organization, who created, and not even the bucket exists in a different organization, even if the bucket exists in your organization, you won't see any transfer job. So you cannot know who exactly did the action. So this is a problem. So how you can still detect it or maybe investigate it and seeing it as something suspicious? First of all, when you enable this service for the first time, you will see the creation of this service account. So you can think about who enabled this service account. Maybe they would try to transfer data. Is this identity is malicious? You can check the storage set IAM permissions on the source bucket. The person which did that probably maybe created the job. The last part, again, is the storage object get that were used by this specific service account. If you see a lot of gets that this specific service account do, you can assume that there is a job going on. And another case, which is not related to logs, if you are listing your resources in your cloud, in your GCP, you can list the transfer jobs. And when you list them using the API, you can see on the right in the console, you can see it, but again, you can use the API too. You can see exactly who created this job and to which destination it will be. So this is another case of exfiltration, which you abuse a different service with a different permissions in order to do the exfiltration for you. So we finished now in cloud storage. Let's continue to another popular service called BigQuery. So if you don't know, BigQuery is a very popular service in GCP. It's the managed analytics data warehouse, and the resources you need to look for regarding to exfiltration are datasets, tables, and views. But of course, there are more. This is an example of how you can query the table inside the BigQuery dataset. In this example, as you can see, I use the console. I search for, I query the table users, and I search for a user which is not external test. Here you have an example of the results. It looks like passwords, but believe me, it's not a real password. And when I'm doing this, what will happen in the logs? So in the logs, as you can see here, you can see it using the Explorer or on the right, the format of the log. There is a element which called metadata, which explained to you what type of query was used. What was the query that was used in order to query the table? As you know, BigQuery is it can include a lot of data, a lot of tables, and you need to know exactly what was queried. So this is what you will see when you directly query the BigQuery table. However, how can an attacker still abuse it? So the attacker can run from a different project context. So if you don't know, you can do something called gcloud config set project and change the project from which you are running from, but still running on resources in a different project. So the attacker can run from a different organization, for example, and just changing the set project and still have permission to do the BigQuery tables get data API and query the result. And what happens when the attacker runs from a different context of a project which exists in a different organization? You won't have any metadata section. So you can't know which table was queried, but who did it, but you won't know the exact query. So you cannot know what was exfiltrated and if the query looks suspicious. So how you can still detect it as something that is suspicious? If you see this type of API, which is for the the BigQuery tables get data, and there isn't any metadata, so you can assume that it is running from a different context of a project which is existing in a different organization, and you can assume that this is something that can be suspicious. Another thing to look for is the identity itself. If the identity exists in a different organization, a different domain, or this is a service account which is not not inside the project, which inside your organization, or something that looks suspicious, look at the identity, check it out, see if this is something that is legit or not. But this is a way for, if you don't see metadata, you can assume that it's ran from a cross organization, which by default looks suspicious. So this is about BigQuery. Now I showed you a way which the attacker can just run queries from a different organization, different context of project, which can change how the logs look like when you're creating TTPs. And the last service that we'll look for is Cloud SQL, which is more like the RDS in AWS. This is the managed RDBMS service for GCP. DBs that they support are MySQL, PostgreSQL, and SQL Server. Resources that you need to look for regarding to exfiltration are the instances itself, the SQL instances, the databases inside those instances, and even read replicas, which can be abused for malicious actions. So now I'll give you a different way the attacker can exfiltrate instead of just directly connect to the DB instance. GCP provides you an API, which probably used for backups, that you can export the SQL data from the DBs to buckets. So you have an API for it. This is something that it isn't a service which you, like the transfer service that there is a different identity that do the job. It's using your permissions. And another interesting thing is that the data, the export dump file, is not encrypted by default. If I am comparing it to AWS, for example, in AWS, you have a way to export data from your RDS instance to buckets, but you have to use KMS keys to encrypt them. But in GCP, you don't have to do that. How it can look like, how the attacker can export the data, you can see on the right. They can use the console or the API. In this case, there is a console. You can choose if you want to export in SQL format or CSV. You can choose if you want to export the entire instance or one or more databases, and of course, the destination, the bucket destination. But let's think about it. Why the attacker would try to use that instead of just directly query the DB? So there are a couple of reasons. First of all, in order to connect to the database, you need to have the right permissions, and you need to have network access to the DB. Sometimes you won't have it. The DB can be internal configured, but yet again, you can still use export SQL if you have a way to just read from the destination bucket. So that's it. You have the data from your DB. So this is a cool way to exfiltrate data. So again, how the attacker can abuse it. The attacker can just run, again, from a different organization or in the same organization as the victim, run the Cloud SQL instance export. They need to have permissions to write to the bucket, of course, and of course to read from the bucket in order to see to transfer the data to them. So on the right, you can see the log format. You can see here from which instance it came from. You can see in the export context in the body the object that will be created and the bucket itself, the format, which is SQL, and how you can still detect it as something that is malicious or suspicious. So first of all, as you saw in the logs, there is the export content. Inside the URI, you have the target, the object that will be created. So you can, from the URI, you can look at the bucket itself and check using asset mapping or some filtering if this bucket exists in your organization. If not, again, this is something that probably malicious or weird, very, very weird. Another thing, you can follow the trail and maybe check if you have data access, of course. If somebody just did get object on this specific bucket, of course, if the bucket exists in your organization. If not, you cannot see that. But if it's still in your organization and you have data access for storage, you can check if somebody download the object, maybe change the permission of the object, maybe change the whole bucket permissions, and then you can follow it and see if this suspicious case turned to be very, very malicious. So this is another case which you can, which the attacker can exfiltrate data. So to summarize everything that you've seen here. So I gave you an example of a simple object get in cloud storage, which the attacker just download data from the object, and you saw why it can be sometimes hard to detect it as a malicious action. Another case, the attacker can just use a different service in order to do the exfiltration for them. So if you don't know that you are not familiar with this service, or don't know that the attacker can abuse this service account, you cannot understand that you cannot detect it as malicious if it's really malicious. In BigQuery, you saw that sometimes using cross-organization queries or any cross-organization actions can change how the logs look like. So when you're writing your TTPs, your detections, you need to check also what happens when the attacker runs from a different organization and still have permissions to run stuff on your resources. And in Cloud SQL, the attacker abused a different API for this case, which seems legitimate, such as for a backup, but still the attacker can abuse it to exfiltrate data. And again, those are simple examples, but there are more regarding to anomalies and abusing other APIs and other services, and abusing visibility gaps that happening inside those logs. So a couple of things to take after this lecture. The first part, the takeovers. The first part is that it's important to proactively to collect those logs regularly. So as I told you in the beginning of the lecture, not all the logs are enabled by default, and you have default retention for every log. So if you still want to have bigger retentions, if you want to investigate better, if you want to send it to SIEM, so you need to check out which logs are enabled and route them using something that's called GCP sync to a different destination, such as buckets, or even using PubSub in order to transfer it to SIEMs, or even BigQuery. But please check which logs, when you come back home to your office, please check which data access activity logs are enabled for which services in all of the projects. And if you collect those logs in a way that if you will have an incident, you can still investigate and check out what happened. The second part is that logs are very, very important, but don't be dependent on them solely. Use some kind of an asset inventory tool, maybe open source, maybe commercial, that can take snapshots from your environment, so you can combine those snapshots with those logs in order to see the full view of the incident. Sometimes the logs miss important and critical information, as you saw in the transfer service. So if you can describe and listing and reading your metadata resource metadata, you can still understand what happened in a day, in an hour. So find a way to scan your assets and save them in a way that you can query them later on. The third part is that you need to understand that understanding exactly what's happening using the logs is very, very difficult. You need to learn about it. You need to know about the little tweaks, about how you can still maneuver some visibility gaps and how it can look like. So learn about the logs, learn about what they can provide you. And the last part is, don't assume the attacker will use the simple form of exfiltration. The attacker can be very, very smart and know GCP, and to do smart exfiltration, which abuses different services or APIs, which can create a situation which look legitimate, but it's not, or even jump between gaps that the security, like for example, as you saw in the DB, if the DB is private, you can still export data from it. So even if the attacker doesn't have network access, they can still read the data from your DB. So know about that. Learn about the ways that the attacker can exfiltrate data from your GCP. And of course, in our company, we publish regularly ways of exfiltration that attacker can abuse. So if you have any questions, I'm here for you. If you have questions later on, I'm on the Slack, or maybe if you want, you can connect. This is a legit barcode. It's not malicious, to my LinkedIn, so you can we can chat and meet up. So I want to say thank you very much for your time. And again, I'm feeling very bad that I'm very bad that I'm not here with you. But yet again, I'm happy that I can still lecture and speak and share my knowledge. Thank you very much, Chief, for being with us. And again, I'm here for questions if you have. So thank you very much.